This is SpaceTime, Series 20, Episode 19. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, the black hole dark matter hypothesis disproved, new evidence for a water-rich history on Mars, and Stephen Hawking's warning of an alien invasion. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has provided strong evidence disproving the idea that unknown populations of ancient black holes could explain the effects currently attributed to dark matter. The findings, reported in the Astrophysical Journal, imply that the detection of gravitational waves generated by colliding intermediate mass black holes can't be used to imply the existence of huge populations of primordial black holes early in the history of the universe. Understanding dark matter is one of the greatest unsolved mysteries facing science today. Dark matter accounts for some 80% of all the matter in the universe. Yet it's invisible. It doesn't fit in the standard model of particle physics, which is the foundation stone of science's understanding of the universe, and it can only be detected by its gravitational influence on normal matter. Until recently, black holes were only known to exist in two sizes. There were stellar mass black holes, a few times the mass of the Sun, and which were generated by the collapse of some of the universe's biggest stars. Then there are supermassive black holes, millions to billions of times the Sun's mass, which form at the centres of most, if not all, galaxies. No one's quite sure exactly how they're created. For some reason, there don't appear to be many intermediate-sized black holes, filling the gap between stellar and supermassive. However, all that changed following the recent detection by the LIGO experiment of gravitational waves generated by merging intermediate-sized black holes, each around 30 solar masses. Astronomers speculated that these could be the long-sought-after primordial black holes. These would be between 10 and 1,000 times the mass of the Sun and would have formed in high-density fluctuations of matter during the first moments of the universe. While stellar mass black hole abundances and masses are limited by models of stellar formation and evolution, primordial black holes, which were likely to be found in the halos of galaxy, could exist in a wide range of masses and abundances. Having detected at least 4 intermediate-sized black holes so quickly in LIGO's gravitational wave observations has raised the possibility that this type of previously unseen black hole may be fairly common. And that's raised the question of whether these black holes could be the long-sought-after dark matter component of the universe. Like dark matter, black holes can be detected by the gravitational effect on the space around them. So, if a significant number of these black holes existed in the halos of galaxies, then at least some of them would cause light from more distant quasars to bend as it travels towards us through a process called gravitational microlensing. The gravity from these black holes would act as lenses, concentrating rays of light and causing an increase in the apparent brightness of the quasar. This gravitational microlensing effect would increase the bigger the mass of the black hole, and the probability of detecting it would increase with increased numbers of black holes present. So, while the black holes themselves can't be directly seen, they'd be detected by increases in the brightness of observed quasars. Based on this assumption, scientists from the Institute of Astrophysics in the Canary Islands and the University of La Laguna have used the microlensing effect on quasars to estimate the numbers of primordial black holes of intermediate mass inside galaxies. Using computer simulations, the authors compared the rise in brightness in visible light and X-rays of 24 distant quasars with the values predicted by the microlensing effect. They found that the strength of the effect was relatively low and well within the range expected from objects with masses of between 0.05 and 0.45 times that of the Sun, and well below the mass range of intermediate mass black holes. The authors also determined that these microlenses form roughly 20% of the total mass of a galaxy. That's roughly equivalent to the mass expected to be found in a galaxy's stars. Their results mean that it's normal stars like the Sun, rather than intermediate mass primordial black holes, which were causing the microlensing effects they observed. effectively ruling out the existence of a large primordial black hole population. The findings imply that the merging black holes detected by LIGO were probably formed by the collapse of stars, rather than being primordial black holes. This is SpaceTime. I'm Stuart Gary. New research on Martian meteorites indicate that the red planet may well have been far wetter than previously thought. The findings, reported in the journal Nature Communications, provide the first clear evidence that a mineral commonly found in Martian meteorites, which was considered proof of an ancient dry environment on Mars, may have originally been a hydrogen-containing mineral that could indicate a far more water-rich history on the red planet. The new findings are based on a detailed analysis of the synthetic version of the mineral whitlockite and another mineral, merlite, which are commonly found in Martian meteorites. Scientists carried out shock compression experiments on whitlockite samples, simulating the sorts of conditions experienced by an asteroid impact ejecting meteorites from Mars. The authors blasted the synthetic whitlockite samples with metal plates fired from a gas-pressurized gun at speeds of almost 1 kilometre per second and pressures some 363,000 times greater than the air pressure in a basketball. One of the study's authors, Professor Oliver Tsuma from the University of Nevada, Las Vegas, says the extreme impacts were needed in order to accelerate material fast enough to escape the gravitational pull of Mars. The team then used an X-ray diffraction beam at the Department of Energy's Lawrence Berkeley National Laboratory's Advanced Light Source to study the microscopic structure of the shocked whitlockite samples, allowing scientists to differentiate between whitlockite and merlite. Separate X-ray experiments carried out at the Aragon National Laboratory's Advanced Photon Source showed that up to 36% of the whitlockite was transformed into merlite at the site of the metal plate's impact with the mineral. The experiment showed that shock-generated heating rather than compression may play the biggest role in whitlockite's transformation into merlite. Whitlockite can become dehydrated from such impact shocks, in the process forming merlite, which is commonly found in Martian meteorites but not naturally occurring on Earth. The study could also have implications for the possibility of life on Mars, because whitlockite can be dissolved in water and it contains phosphorus, an essential element for life on Earth. The pressures and temperatures generated by the shock experiments, while comparable with those for meteorite impact, lasted only for about 100 billionths of a second, or about 1/10 to 100th as long as an actual meteorite impact. Schooner says the fact that the experiment showed partial conversion to merlite in lab-created conditions indicates that a longer duration real-life impact would likely have converted most, if not all, of the whitlockite into merlite. He says science's picture of the water budget of Mars would be changed dramatically if some of the merlite was originally formed as whitlockite prior to impact shock. There's heaps of evidence that ancient Mars was a warm, wet world. The evidence includes orbital images of dried-up river channels, lake beds and seashores, as well as surface analysis of minerals and geological formations which are only created in the presence of liquid water. Then in 2013, data from NASA's Mars Reconnaissance Orbiter showed what appear to be seasonal darkish streaks appearing on Martian slopes. Known as recurring slope lineae, these are thought to be briny meltwater from subsurface permafrost deposits which partially melted as a result of seasonal temperature changes. The only missing link now is to prove that merlite was in fact really formed out of whitlockite by impact events. Schooner and colleagues are now going back to examine real Martian meteorites rather than synthetic ones to see if there's any traces of water. The authors plan on pursuing a new round of studies using both infrared and X-rays to examine Martian meteorite samples later this year. Many Martian meteorites found on Earth all come from the one period between about 150 million and 586 million years ago. They're most likely also all from the same region of Mars, probably as ejecta blown off the planet by a single impact event. It's believed the meteorites were probably excavated from a depth of about 1 kilometre below the Martian surface by the initial impact which sent them into space. However, the best evidence for past water history on Mars would come from an actual Martian sample return mission, which could provide rocks that hadn't been affected by events such as asteroid impacts, long periods in the deep freeze of interplanetary space, or from the heat generated through atmospheric entry to Earth. I'm Stuart Gary, this is SpaceTime. Okay, time to take a quick break from the show and talk about one of our sponsors. Yeah, there are many times when you can't hold a book, but you can listen to one, such as when you're commuting, when you're at the gym, jogging, or walking the dog. And that's when I listen to Audible. It's my audio bookstore. And you know, I love the idea of someone reading to me. And no one offers a greater selection than Audible. In fact, they've got something like 180,000 titles plus to choose from. Audible's great if, like me, you have an unquenchable thirst for knowledge. Audible means you can learn so much. And right now, Audible has a special deal for SpaceTime listeners. Audible's offering a free audiobook download with a free 30-day trial to give you the opportunity to check out their service. And they've got so many great books to choose from. All the bestsellers, the classics, science fiction, science fact, history, biography, whatever, often from the people who actually wrote them. How about Born to Run by Bruce Springsteen, narrated by Bruce Springsteen? Or The Life of Keith Richards, narrated by Johnny Depp, Joe Hurley and Keith Richards himself. No matter what your taste, there are over 180,000 titles to choose from. To download your free audiobook today, go to audibletrial.com/spacetime. That's audibletrial.com/spacetime for your free audiobook. Or just click on the link at spacetimewithstuartgary.com. And now, back to our show. Theoretical physicist Stephen Hawking says he believes that while intelligent alien life probably does exist elsewhere in the universe, making contact with them could be as disastrous for humans as Christopher Columbus's arrival in the New World was for Native Americans. He made the comments during the launch of his newest documentary, Stephen Hawking's Favourite Places. The 26-minute program uses computer-generated images to visit various destinations across the cosmos. Hawking says in a universe containing hundreds of trillions of galaxies, each containing billions upon billions of stars with planetary systems orbiting them, it's highly unlikely that the Earth is the only place where life has evolved. But he warns that distant alien civilizations receiving messages from Earth could be far more advanced than anything we can imagine. He says that means they could be far more powerful and could well see us as little more than bacteria. It's not the first time Hawking has warned about the potential dangers of alien contact. During the launch of the Breakthrough Listen project with Russian physicist Yuri Milner back in 2010, Hawking said intelligent aliens may have used up all their resources and so are now looking for other places to rule. He thinks there could be rapacious marauders roaming the cosmos in search of resources to plunder and planets to conquer and colonize. Thus, making contact with them could be very dangerous. To find out more, Andrew Dunkley speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
Going to focus on a fellow who tends to have a lot to say about astrophysics and the universe and everything else out there, including life, and that is Stephen Hawking. And he has gone public on our search for extraterrestrials saying, hey, look, we better tone it down a bit. We don't know what's out there and we don't want to wave our flag and attract the wrong kind of people. Is that basically what he's suggesting?
I think that's right, yes. And I mean, what's very interesting here is that Stephen Hawking is, of course, one of the world's greatest living physicists, but he's also a keen and enthusiastic player and contributor to the Breakthrough Foundation's 3 projects. Breakthrough was launched about a year ago, a bit more than a year ago, a year and a half ago, with 3 branches to it. One is Breakthrough Listen, and that is exactly what the name implies. It's about using 2 very large radio telescopes, one of which is here in Australia, the Parkes radio dish, to listen for any signals that might be of a non-natural origin. So artificially produced signals like airport radars. They reckon they can detect an airport radar to 30 light years.
Seriously?
Pretty fantastic going, yeah. So that's the kind of thing that Breakthrough Listening is looking for. It's like a super SETI being the search for extraterrestrial intelligence. And then there is another branch, and that is Breakthrough Starshot, which is the idea of developing small, what are called nano spacecraft. These things are only a few centimeters across and weigh next to nothing. Their weight is measured in grams rather than kilograms. But fit one of those with a solar sail, a very lightweight but large area structure, and then blast laser beams at it to propel it through space at an ever-increasing speed, with the idea that you might reach the solar system of the nearest star other than the Sun, which is Proxima Centauri, which we know has an Earth-sized planet around it. It might reach that within maybe 20 to 30 years if you can achieve a significant fraction of the speed of light. So very ambitious but exciting stuff. But the third branch of the Breakthrough Foundation is something called Breakthrough message. And that's really about the idea of designing a digital message that could be transmitted from the Earth, a message that's representative of humanity and the planet Earth. But there is also a really significant aspect of breakthrough message, which is to discuss the ethics of doing that, because there is a risk to it, as Stephen Hawking has pointed out. So the breakthrough message program includes the statement that it will not transmit any message until there has been a global debate at high levels of science and politics on the risks and rewards of contacting advanced civilizations. So Stephen Hawking's version of that is, let's just listen rather than talk.
Yeah.
As he says, use our ears, not our mouths. In other words, to eavesdrop, but not necessarily join the conversation, has been widely quoted on the conversation.
But the problem is we've been telecasting, broadcasting and transmitting thousands upon thousands of radio signals for, over 100 years. We're already lighting the beacon, aren't we?
That's true. Indeed, that's exactly true. We have been a radio noisy planet since the 1930s when, high-power radio transmissions started being sent. But those transmissions, because they're not sort of focused on any particular direction in space, they dissipate relatively quickly. So it's unlikely that beyond a light year or so from the Earth, and there aren't any solar systems within a light year, you wouldn't be able to detect those signals, that they've basically become undetectable. However, the alternative, though, is to beam a signal towards a likely target. That has actually been done in the past just to test some systems. I think it's been done twice, beaming a signal a particular direction in space, without the ethical discussion beforehand, I have to say. And so breakthrough message is taking this a bit more seriously. And of course, Stephen Hawking is one of the voices that says, look, think of the Spanish conquistadors in Central America and South America and what happened to the Aztecs and the Incas, because you've got an advanced civilization that basically decimated a civilization that in its own way was advanced, but wasn't quite as advanced in that they didn't have guns and, they didn't have horses, the wherewithal to fight. Yes, that's right. That's a lesson that Stephen Hawking is putting out there, and he's saying, my voice is one of caution rather than a gung-ho, let's go and send messages out all over the universe, which is, I think, a very interesting take on this great man of physics.
Yes, indeed. And of course, there's always the worst case scenario that they'll be more advanced than us. And if we're waving the flag saying, hey, here we are, we could be inviting trouble. I mean, that's a pretty extreme way of looking at it. And you're sort of delving into the realms of science fiction, but, never say never, I suppose.
That's correct. There's a little bit more to it than that, though, Andrew, in that if you look at the age of Earth-like planets that we've found so far, spread throughout our galaxy, the average age of them is about 2 billion years longer than ours. So if their life formed 2 billion years before ours, who knows what it might be. It might not be there, of course, but it might also have evolved in a very different way from what life has evolved on Earth. So we are maybe relatively latecomers to the galactic technology boom. And, that might be why we're not seeing the other civilizations, because they've gone into hyperspace or something like that.
It's also possible that they've become extinct for some reason. They've lived their civilization's lifespan and something's wiped them out, so they're not there anymore. I mean, that's a possibility if you're talking 2 billion years. Yeah,
2 billion years ago, we were basically bacteria.
Yeah. Wow. Okay, so we've got some catching up to do. Or maybe we've already caught up and we don't even know it. Yeah, it's all science fiction. Of course, science fiction generally is well ahead of reality in terms of science, and science fiction always says the aliens come and attack us. So I think we should, take stock. Be very careful.
Be very careful.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program Space Nuts. And this is Space Time. I'm Stuart Gary. A new top-secret spy satellite has been successfully launched into orbit for America's National Reconnaissance Office. A United Launch Alliance Atlas V rocket in its 401 configuration blasted off from Space Launch Complex 3E at the Vandenberg Air Force Base in California, carrying the classified NROL-79 National Defense payload. The mission, originally slated for last December, had been delayed by local wildfires around the Vandenberg Canyon area. When it did finally launch, the Atlas V blasted off into clear blue skies under ideal weather conditions.
Stable at step 3.
Status check. Go Atlas. Go Centaur. Go NROL 79.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition of the RD-180 main engine. 1. Liftoff of the United Launch Alliance Atlas V rocket carrying the NROL-79 mission for the National Reconnaissance Office.
The core stage's single Russian-built RD-180 kerosene and liquid oxygen engine burnt for just on 4 minutes, pushing the stack high into the atmosphere.
Roll program is complete. Body rates continue to look good. Booster engine continues to look good at this point in flight. Pump speeds, injector pressures, right in band. Current altitude is 18 miles, downrange distance 14 miles, current velocity 2,479 miles per hour. Booster is now 1/2 its liftoff weight. General responses look good. RCS pyro valve fired. Now pressurizing to flight levels. Signatures look good. Current altitude is 31 miles, downrange distance 43 miles, current velocity 4,458 miles per hour. Body rates continue to look good. Currently accelerating at 3.3 Gs, and closed loop steering has been enabled. All looks good. Booster has throttled down, as expected. Engine signatures look good. Currently at 50 miles in altitude, downrange distance 98 miles, current velocity 600 miles per hour. Boost phase chill down is underway. We have fired the pogo pyro valve. Boost phase chill down is complete. We are throttling to 4.6 Gs in preparation for BECO. And we have BECO. Engine shutdown looks good. We have stage separation.
Following MECO, or main engine cutoff, and stage separation, the launch vehicle's Centaur upper stage ignited its single liquid hydrogen and liquid oxygen-fueled Aerojet Rocketdyne RL-10C1 engine to bring the classified payload to its orbit.
We have LOX and fuel pre-start on the RL-10. GN2 purge firing the RCS is underway. We have ignition and full thrust on the RL-10. The pressures look good. And we have indication of payload fairing jettison. Looks like a good step.
Shortly after upper stage ignition, the payload fairing separated, exposing the satellites. NROL-79 is believed to be a pair of Naval Ocean Surveillance System, or NOS, intruder satellites. The 3,250-kilogram spacecraft are designed to detect and monitor both aircraft and shipping movements from 1,200-kilometre high orbits for the National Reconnaissance Office and the US Navy. The Lockheed Martin-built spacecraft are believed to have an 8-year operational lifespan. The launch was the second flight this year for the United Launch Alliance Atlas V rocket. It was also the 117th successful launch for the Boeing-Lockheed Martin joint venture, which formed in 2006. The United Launch Alliance's next flight will be a Delta IV carrying the WGS-9 satellite for the United States Air Force. It's slated for launch on March the 8th from Space Launch Complex 37 at the Cape Canaveral Air Force Base in Florida. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from SpaceTimeWithStuartGary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for SpaceTime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.